Okay, microphone is on, hopefully. All right, let's say we have a question on our test, hint, hint, that might look something like this. E to the 2x minus, let's say, 5e to the x. Nice try. Minus 6 equals 0. Okay, so this is actually a quadratic equation. Okay, and why is that? That's because e to the 2x is just e to the x squared, right? Yes, agree? Guys, this is useful, so please pay attention. Jaden? Kellen? All right, so this is really just a quadratic equation. And so a great way to start is simply by substituting y equals e to the x. Okay, so if y equals e to the x, that means our first term here, e to the 2x, that's just y squared, right? Y squared minus 5y minus 6. Of course, we all know how to factor this. This is y minus 6 times y plus 1. And so that gives us y equals -1 or positive 6. Okay? So that simplifies into two cases. Either e to the x equals -1 or e to the x equals 6. All right? Now, is this possible? E to the x equals -1? No, it's not possible, right? Because an exponent can never be a negative number. And so this is a no-no. Okay, is this possible? Of course, right? If we take a natural log of both sides, we are left with x equals ln of 6, and that is our final answer. Okay, so you're going to encounter this sometimes, and it would be useful to know, but the general idea is that we just want to substitute y equals our exponent when we have a quadratic like this. Sometimes you guys might encounter something like this, maybe like 9 to the x minus something, 3 to the x plus something, okay? Not 6, 3 to the x, okay? Is this also a quadratic? Yeah, it actually is, right? Because 9 to the x is simply 3 to the 2x, right? So 9 to the x is also 3 to the x squared. And so this is also a quadratic in terms of 3 to the x. So we can apply our same process and substitute y equals 3 to the x and solve this. Got it? This is how we do these kinds of questions. Any questions?